Daylight brings Bashar a string of problems.
Bashar, come here, we've got another problem. 805 that way. Oh, that's 795 that way.
Was it perfectly round before?
Which shrinks across the grain and shrinks very little down the grain.
It's from the heat of the iron?
The heat of the iron has speeded up the shrinking.
Oh my goodness, of course.
So what we should have done is cut an oval. Yeah. An egg shape.
Yeah, to compensate for it.
I'd like to just make sure that we establish a very clear sequence of events that once the...
To add to his troubles, Bashar faces a mutinous crew.
Stones into the arch. That's it?
Bashar is keen to discuss the plan of attack. The builders just want to get on with the job.
Drawings never seem to be that clear and snags are always hit. And we have to change things appropriately as we carry on.
Well, they're like football commentators, aren't they? You know, they talk about it, but they don't play.
Yeah.
Julian's design put all the weight of the crane on the bottom of the mast. Bashar is worried that if the mast leans forward, it will pull the base supports out of their sockets. To anchor them in, he wants to transfer the weight of the mast to the top of the base. The small bearing they've already made will be supplemented with a new, larger bearing. Both bearings will be attached halfway down the mast. The larger bearing will sit on top of the support frame and carry the entire weight of the crane.
What's that?
That's about it, Edge, I reckon.
30 mil and a teenth. That'll do.
To soothe his growing anxiety, Bashar escapes to the nearby town of Coutances, which is dominated by a spectacular Gothic cathedral. 800 years after it was built, it is still the highest building for miles around.
Damn impressive. It gives you this sense that there is almost a divine intervention here. You almost want to say, my God, it's not possible that people could have built this. Well, I've seen quite a few things that I wouldn't dare do today. They had a lot of balls.
Medieval crane builders face challenges that Bashar is only beginning to grasp. In medieval Europe, every town wanted a cathedral, and every bishop wanted his to be the best.
How to outdo the cathedral next door? Well, one way of doing this is certainly to build higher, and therefore to be more impressive. It certainly feels that people were in competition.
Medieval bishops competed with each other to build higher and higher cathedrals. In 1163, work started on Notre Dame in Paris. At 48 meters, its choir was a third higher than anything previously attempted. Gothic architecture called for thin walls filled with large windows, a delicate structure which gave little support for the roof above. To keep Notre Dame standing, its architect pioneered a new invention, the flying buttress. Like rows of giant ribs, they stopped the arches in the center of the cathedral from falling down.
The problem with the arch when you put it at the top of high walls is it creates a lot of thrust on the outside. To transmit the force from the top of the walls to the outer buttress, they introduced this concept of a flying buttress. And this transmits the force from the top of the wall to the outer buttress. This is why if you take out the flying buttress, the whole thing would collapse.
Flying buttresses enabled the cathedral builders to go higher than ever before. 30 years after the completion of Notre Dame, Christianity was on the march. New cathedrals sprang up at Chartres, Reims, and Amiens, each one taller than the last. In 1225, work began on Beauvais. At 150 feet, this cathedral was tall enough to enclose a 14-story building. It has never been surpassed. It remains the highest cathedral choir in the world. The race to build high raised new engineering challenges. At heights over 30 meters, the builders experienced far greater wind speeds than they had encountered before, further complicating the tricky task of positioning stones. Working at these heights called for steady, powerful cranes. The medieval crane builders are preparing for their first lift. To assemble their crane, they need to erect another crane, a tripod or A-frame. They've brought in rigging supervisor Wes Moore to make sure there are no hitches. To help erect the tripod, they've enlisted every spare able-bodied man in the village.
All right, here we go. 1, 2, 3. And deux, trois. And deux, trois. And deux, trois.
Out the way, Dan. Lever.
And deux, trois.
In less than 20 minutes, the tripod is in the air.
Very, very pleased. This is the first big lift. Second big lift's there. The rest of the crane.
Cheers, boys.
But before they can raise the mast and jib arm, there was one more problem to sort out. Bashar wants to make sure that the crane will rotate. The pivot point is the bearing halfway up the mast. Too much friction here, and the crane won't turn.
My feeling was we put metal on metal.
Yeah.
And then grease the interface, and this way we can reduce friction.
When you will have 4 ton in it,
Yeah.
the grease, will totally squeeze out. To keep the grease in, you need, for me, to make a kind of smooth washer, full of grease. After that, you can compress. You have a kind of mattress, a soft mattress, full of grease, and this one will still move forever.
Smart man.
Adopting Roland's idea, rope is wrapped around the collar. The top and sides are greased, ready for the bearing. The team are finally ready for the biggest part of the operation, raising the mast and jib arm.